Well, the last talk I had to ask if anybody in the room was doing .NET programming. This one, I would like to presume you are, because it's a .NET specific topic. And the funny thing is we're so close to EF Core 7 release, but I really thought about it, and I still think it's very relevant to talk about EF Core 6, because who really jumps, like, throws the new thing into production right away? Is everybody here using some version of EF Core? Okay, 6? 3? Did I hear? Oh, we're on 6. Anybody lower than 6? Okay, that's still safe. And anybody here on EF6? There's a lot of good reasons to still be on there, like applications in production with a lot of users. You know, there's that. Awesome. So, so what I'm going to do is make sure give you an awareness of some of the really great innovations in EF Core 6, and also the interesting what. Can you say that again? It's touching the mic. What is? Here we go. My lanyard? Oh, just take it off. I don't need that. Now somebody's going to be like, oh, I just heard Julie Lerman say, just take it off during her presentation. So an important thing about EF Core 6 is it is a long-term support version of EF Core, right, for 3 years. EF Core 7 will not be. And so what I'm going to do is, Entity Framework, you know me, right? You know me in Entity Framework probably. I want to tell you everything I ever learned since 2008, so I will have some self-control. So I refer to this as the bucket list because with EF Core, by the time the team got to EF Core 6, they really had done a lot of important groundwork and gotten some key things fixed for people. And they were finally able to really start working on things that they really wanted to get done but weren't quite as critical. Right, like, you know, just as an example, the kind of thing in EF Core 5 that they were able to do was give us better many-to-many support, right? We had all those versions of EF Core, we had another way to do it, right? So, you know, by the time they got to EF Core 5, they finally got to work on it, right? Because now you have a better way. So EF Core 6 is where they're continuing to kind of work on that bucket list. And it's not just their bucket list, it's also our bucket list. It's like a collection of things that they really thought were important that they needed to work on and things that the community's been asking for. I do want to mention that I've got an EF Core 6 fundamentals course on Pluralsight. There's actually a whole path. And there's a number of different authors working on that, and I think there's 5 courses out now already. So mine is fundamentals, and then there's some kind of intermediate level and advanced courses. And I'm about to start on a EF Core 6 and domain-driven design course. So as you may know, the EF Core now is in the same cadence with .NET releases, and EF Core 5 came out with .NET 5. EF Core 6 comes out with .NET 6. So .NET 6 is long-term support. EF Core 6 is long-term support. .NET 7 is coming out shortly. Nice thing to know about .NET 7 is it will run on, EF Core 7 is that it will run on .NET 6. So you can at least be taking advantage of the long-term support of .NET 6. It's so nice not to also have to talk about .NET Standard at the same time because that was always like so confusing. And the other thing to know is EF Core 5 support. Now support is not, you know, answering questions on GitHub. It's more, you know, getting actual support from Microsoft. So EF Core 5 support did end in May. 3.1 was long-term, so, end of this year, it's going to be out of support. So just some key things to be aware of. So yeah, EF Core depends on .NET 6, not .NET 5, not .NET Standard, and that also means no .NET Framework anymore, right? Because .NET Framework got moved to .NET Standard. Just .NET 6 and those IDEs that work on .NET 6. So Visual Studio 2022, VS Code and JetBrains, of course. So first big topic, they really hammered on query performance this time around. Specific focus was query performance for untracked queries. Okay, so not queries where the change tracker is involved. And I'm saying these things with an assumption that you know what I mean by the change tracker. So that is pretty specific, but still they made huge gains. And what they did was, first of all, they targeted Dapper as for kind of a benchmark, right? Because people are always like, oh, Dapper is so much faster, which it is because Dapper is much more down on the metal than EF Core is. And they didn't do it because there's a competition between EF Core and Dapper, because, I mean, you use the tools that work for you, right? And there's a lot of hybrid applications for reasons to use them in a hybrid way, to use them both. But that was a good thing for them to kind of, like we need some kind of a target. So they targeted Dapper to a comparison to Dapper, and they focused on the Tech Empower Fortunes benchmark. So Tech Empower's Fortunes test is about like a very specific setup. So everybody all the technologies in there, they have to follow very strict guidelines so that they are really comparing apples to apples as they go through it. So they used that as their standard and then just started hammering on EF Core 6. So overall, with Tech Empowers is full stack, right? So it's .NET, ASP.NET. So it's very specific web access with data involved, with data retrieval involved. So the combination, .NET 6 performance improved a lot also, right? So that has an impact as well. So a combination of .NET 6, ASP.NET Core 6, and EF Core 6, comparing that to the Tech Empowers, using Tech Empowers to how it ran in .NET 5, they discovered it was 70% faster in EF Core 5. I didn't mean .NET 5. Well, actually, .NET 5 plus ASP.NET Core 5, and yeah, that combo. So 70% faster. Then when they just focus on EF Core 6, take those other factors out, they still found with all the benchmarks that it was 31% faster. And this all comes from a really detailed blog post by Shai Rojansky on the team, and he's the performance guy. Holy smokes. So this is the blog post. And so they did that. It's okay. Hi. So just a little bit more on some of the numbers they presented in this blog post. So what they did was they started with just EF5 and .NET, EF Core 5 and .NET 5. And the Tech Empowers benchmark was 147,000 requests per second were coming through. Dapper was 231,000 in that same benchmark. So they're version-wise, they're comparing apples to apples. So there was a really, really big gap. So the first thing they did actually was they fixed the test to make them more in line with what Tech Empowers requires, and that actually brought their numbers up a little bit, so that was good. Then they took still with EF6, still with EF Core 5, they just moved .NET 5 to .NET 6. So that just, isolates the performance gain we're getting from .NET 5. So that was some of it. And then when they, the last thing they did was they switched from EF Core 5, took the whole thing, switched from EF Core 5 to EF Core 6, and still they had this 32% gain. That's where they got that number. The benchmarks are actually interesting to look at. I mean, you like data, right? I like data. The benchmarks are cool to look at. Oops. Oh, okay. It's not clickable. Duh. Fine, be that way. I think this will remember it. Oh, remember I was like, oh, I'm getting all these, I'm not going to bother. I was getting all these text notifications and everything, so I turned off the internet. Anyway, if you look at it, you can see where the one for middleware, PostgreSQL, entity framework, it was looking at benchmark from 20, benchmark number 20, when they, the official results. That was like in May of 2021, so it was just before they released EF Core 6, well, just, 6 months before. It's just, first of all, EF Core and Dapper with .NET 6, they were way down. And so compared to hundreds of other platforms, right, hundreds of other technologies. And then with EF Core 6, .NET 6, et cetera, both of them came way up. And, they were just so much faster. Some of the things that were done to make it faster, some of the places, they're just going to happen. It's underneath, right, under the covers, performance tweaks. But are you familiar with the pooling, the DB context pooling that's been around for, I think, since the beginning of EF Core? So what they did was they added to the pooling, so now it also pools by default connections and commands and data readers, all kinds of internal objects. So that is responsible for a large amount of the performance gains. They tweaked how interception and logging works. This GitHub post, again, that the GitHub post I referenced earlier points to this issue where all the things are detailed. I find it really fascinating. I don't want to completely bore you with it, but the way logging was working was they were checking it like so much, even if you weren't using logging. And the interceptors is like, are they looking for something? Is this the point? Is this the point? Is this the point? So they changed the algorithms of how all that works. That also made a big difference. There's some other more minor things, but one thing that is something you would explicitly do is you can opt out of thread safety checks. So before EF Core 6, the thread safety checks are happening whether you're in dev or in production. By the time you get to production, you shouldn't be needing those anymore, right? You should already know that everything's cool, everything's safe, right? So they do give you an opportunity to opt out of thread safety checking, which is, you wouldn't do that during dev and test, maybe, but you would definitely take advantage of that during, when you release to production. So those are some of the things that were done. And again, just making sure you're clear that all these tweaks, the focus was on non-tracking queries, okay? They said that what they were hoping to do when it came to EF Core 7 was start focusing on the tracking queries and see what, take all the things that they learned with this performance improvement and start applying them. But I talked to Shai about it, and he said that they did a lot for performance in EF Core 7, but they didn't do that. What they focused on was actual safe changes, the kinds of things that are commands that are being generated and round trips. And just as an example, and I'm not going to get too deep into this, but I did just write a big article about a lot of these changes for EF Core 7. But just as an example, you know how when you call safe changes, it creates by default a DB transaction around the whole thing, everything that's getting sent up, even if you're only sending one command, right? And they're like, oh, right, we don't need to roll, if it fails, we don't need to roll anything back. So just all kinds of things like that, maybe kind of small, but really looking at patterns that have been in there since the very beginning of EF. So that's pretty interesting. So the numbers I've been showing you were from their big benchmark, big tests with multiple servers and, all the things that are required from Tech Empowers. I did a little baby test on my computer, so I called it a backyard benchmark test. Are you familiar with if you like doing this kind of stuff, are you familiar with benchmark.net? It can take code that you want to test, and instead of you having to put in all those points of timer start and timer stop and throw away the first one and throw away the last one and do a warm up and all that kind of stuff, benchmark.net takes care of all of that. So you can just feed it the process that you want to test, and then it will do all of that other stuff for you. It's open source, and it comes from the .NET team, within .NET team, but it's on GitHub, and you can get it. So it's really cool if you're interested in doing that. So I did a little, just this little app here where, and I created this with Shai's help. I'm building up a DB context factory and running a query in a way that I'm kind of trying to strip away all the other kinds of processes so that benchmark.net's really only going to focus on the actual query itself. So, even pre-compiling the query, right? So when it comes to running the query, I'm not even doing query compilation, all that startup stuff that's really expensive for Entity Framework to do. So what this is doing is I'm doing a query against a fairly large database, and I'm just saying, just go get 1,000 things. Don't even do anything with them, but just iterate over the results so it knows we're really getting all of them. And then this one only goes and gets one thing using that precompiled factory. So that was my little code. I am definitely not running it because benchmark.net does a lot of work, right? Because it does like 100 tests and then all of this other work to, the averages and everything. But comparing EF Core 5 on .NET 6, right? Because I didn't want it to be about the speed improvements from .NET 5 to .NET 6. So I was using EF Core 5 on .NET 6. And when I ran the 1,000, it took 3 seconds, 3,000 microseconds. And running just to grab one thing, it was 487. And then taking that same code, adding one thing to it that you can't do in EF Core 5, which is disabling the checking. Oh my gosh. Pardon me? Thread safety. Thank you. Disabling the thread safety. So that's the only thing. Otherwise, they're doing the same thing with pooling and everything. Querying for the 1,000 went down to 1,500, so it was about half the speed of that. So, I love doing stuff like that. I hope it's not too horribly boring. Anyway, so that's query performance. Except for the disabling the thread safety checks, explicitly and make sure you know when to do it and why to do it. Everything else just happens. You just get that for free with EF Core 5. So the next performance tweak that we got was startup performance. Do you remember in EF6 we had a way to precompile models because the compilation is actually really expensive. The startup cost of getting a DB context in memory the first time in an application process that you're working with that you're actually doing something with it. It's a really expensive process. So just to be clear, if you're not familiar with how that works, instantiating the DB context is not an expensive process. But the very first time you do something with the database, right? So you're doing a query, you're doing a save, or something with the database, that's when EF Core says, oh, wait, I need to know what the model is. It doesn't bother doing any of that until you really need it. So that's nice, and that's always been the way. But that's a really expensive process. So that's compiling the model. And once you've done that in your application instance, it doesn't need to do it again for that context. It just does it once. So if you're talking about a web app, that instance of that web app, for as long as the lifetime, that web app is running, that's done. It doesn't have to do it again. But if you're talking about a client-side app or something like that, where it might be happening frequently, it might be more noticeable. And so, oh, that's funny. I thought I switched this around. I want to skip this. Yeah, I just want to make sure you're aware of what happens when you're compiling, and this new feature of pre-compilation, what it avoids at that moment, right, that you need to have the model in memory. So it has to read the DB context, then go and look at all the classes that the DB context makes reference to, whether it's by a DB set or you've just got some model configuration or something like that, on model creating. So that it looks at all of those and it figures out what the model ought to be based on convention, right? It hasn't looked at your special configurations yet, mappings or data annotations. So it says, okay, that's where we're starting. Then it looks at all of your configurations, whether they're Fluent API mappings or data annotations, and applies all of those to the model. And then that's what it creates. So it's actually a lot of work. And if you've got a big model, it's a lot of work. So Arthur Vickers is like the senior engineer on the EF Core team. He's brilliant. They really all are amazing. So he has this demo where he has a huge model. There's like almost 450 entities, 6,400 properties, and 720 relationships. So when they started talking about the fact that they've got this pre-compilation that's going to really help with large DB contexts, large models, I don't know if you know, I do a lot of work with domain-driven design, and I'm like, why is anybody using large models? They shouldn't be using large models anyway. They should be, dividing them up and having bounded contexts and creating DB contexts just for those. And they're like, yeah, but there's still a lot of applications out there that have really, really, really big models, and we want to help them. And so, I figure that's fair. Anyway, so he built a demo model that represented something like that. And he also, using benchmark.net, he found that that first interaction with the database, without pre-compiling, just letting it work the way it normally works, versus using a pre-compiled model, was more than 10 times as fast. It's really, really big. Okay, so here's how you pre-compile models. That doesn't happen on its own. That's not a freebie. And you can do it whether you're using the CLI or using PowerShell commands. So in the CLI, it's .NET EF DB context optimize versus optimize -DB context if you're in PowerShell. And what it does is it creates a folder filled with all the assets it needs related to pre-compiling. And then you have to tell the DB context to use that instead of doing its normal thing. So I want you to see what those look like. So you have some kind of understanding about that. And I've got a lot of branches here for all this. So compiled models. Yeah, I know. Okay, are you happy? All right. Okay, so I'm going to run that command in here. Where's my prompt? Oh, because it's output. Okay, so .NET EF, and I guess I should show you my model. It's just dumb. There's a person type, there's an address type, right? A person has a one-to-many relationship with addresses, and I also have an address, and then I also have an address type enum. So it's very, very simplistic, right? So this is not going to benefit, but this is just so you can see, because I don't want to show you how this works with his gigantic model, because you can't see the trees for the forest that way. So that's all I have. And then the context itself is, again, stupid simple, and I'm not even doing anything special in the mappings. So .NET EF DB context optimize. And that little squiggly line is just because OmniSharp gets really pissy about me changing the branches. Okay, so it's building. Oops, don't. I just exposed my tests from before. We'll see that in a minute. This is what you want. You want .NET. So I guess I got to get OmniSharp happy again. I made myself a shortcut. Okay, .NET build. Oh, for God's sake. And people are always like, why don't you just use a Windows machine in Visual Studio? Okay? Are you happy yet? Or they say, why don't you just use JetBrains Writer? My friends at JetBrains. Oh, come on. I know this works. I've used it a million times. I'm at compiled models before. I guess I better read this. Oh, come on. You see it? Unable to load the service index. Oh, it doesn't have everything downloaded. All right, so if my neighbor sends me another text message about the cat who finally came in, our friends are away, and their cat has been outside for 6 days and nights, and we haven't been able to get her in. And she just texted me to say, oh my God, I got Willow in. And 2 of our other neighbors' cats disappeared. They have been gone for a week and a half, so I'm just filling time here. I can't believe I turned the internet off. I know, Westin guessed. Oh, that's what's going on. Okay, yes. Thank you for realizing what was going on there. I've only been using .NET for 20 years, and I just didn't even get that. It's because I go, oh my God, something's not working, and I don't read the error messages. That's normal, right? Right? You're just like, what is it? Yeah, yeah. With, tick, tick, tick. Okay, so where was I before I was rudely interrupted? I want to precompile. Yeah, it would be nice if the command was precompile when it's called precompilation, but it's optimized because that's what they're doing. Okay, so it successfully generated a model, and there's a new folder there. You see compiled models? So what it did was for each class that it found, it created one of these entity type classes. And the entity type class has everything it needs to know about that entity already figured out. So it's not going through that whole process of what are the classes, what are the conventional mappings, where are the, what are the mappings that you've applied with Fluent API, and putting that all together. It's all, whatever you have, it's all in here now. So that's for the address. And the address also has, which direction? Okay, yeah, the foreign key, right? It has all the foreign key information it needs. So it's not just things that you would have configured, it's everything. It's all of the conventions and you know, and then anything you added on top of that. Everything it needs to know about the address is in there. Same with the person entity type. This model builder then says, you know, when it's time to build a model, you want to get the address entity type and the person entity type, and it, you know, creating the foreign keys and some annotations, and you know, here's what you need to pull together. So that's instead of looking to see what do I have for DB sets, what do I have listed in on model, what entities am I using in on model configuration or on model creating, what entities are maybe not in either of those, but they're discoverable, you know, related to another entity, right? So it doesn't have to go through any of that. It's just explicit right here. Here are the entities you need to know about. Once all of that is there, then I'm not going to actually go through this. Then just for time, but this is when you would go in and append on model configuring, and here's where you would say use the model. Right, and you would point to an instance. It's not just the model. I showed the code here. It's the context model dot instance. So you would just use that model, and then when it runs, it does that instead, and that's the magic behind it. Does that look like something anybody can benefit from? Oh, good. Otherwise, I should have asked in advance. Does anybody need this? Fine, I'll skip it. No, as a matter of fact, EDMX is not even a thing in EF Core. Ah, you got a little learning to do. So one thing I'll, that was, well, I mean, it's true. There's going to be a learning curve for some of these concepts. However, a lot of what we know from EF6 is in EF Core. Absolutely. So, you know, they only pulled the rug out from under people using EDMX. Sorry. But, you know, supporting both of them. And by removing EDMX from the whole workflow, it allowed them to do so much more with EF Core. Yeah. Yeah, yeah. Anyway, so, however, yeah. I don't know. I don't remember if EF6 pre-compilation worked with that. So, so anybody who was in my talk earlier today might laugh about this one because I was doing a completely different way of using migrations, but it's still important to know another feature which is called migration bundles, and what that does is it takes all your migrations and makes them into an executable that you can run. So I'll just go through this a little bit to make sure we're all on the same page here. So migrations, when you're deploying to the web, it's really tricky to know where to put that. A lot of people will just put it in app startup, right? Ensure deleted, ensure created, or use the migrate. There's actually a migrate command. And that gets to be a problem when, you know, you start having multiple instances of your web app. You know, maybe you've got a bunch of different containers or something. You've got you've scaled your application up. And then each one of these instances has that command in there. And there is a good possibility that they might, you know, somehow run at the same time. Like, so it's really an anti-pattern. It's something you should not do. So we don't do it that way. Or generate the SQL script and feed it to your favorite tool, like FlyWayDB, like I did earlier today, right? That's another way to do it. So I like that, but not everybody's using Docker and containers and orchestration and all that. So this bundle migrations feature lets you take your migrations and So it's the actual migrations file. I don't have to generate the SQL script first. It takes the migrations, it bundles them up, and turns them into an executable. And there's a few flavors of that because you can create an executable that will run somewhere you've got .NET already running. So if you are putting in a container, you'd have to have a .NET container. But you can also create an executable that has .NET in it. So it'll be completely independent. You can just run it. Another point about it is that it is idempotent, and I tested. I'm not going to demo that part of it, but running it and then making a change, and you still have 3 migrations, right? And run it, create a bundle, and execute it, and then you add another migration and you create a bundle. It'll check as it's applying them. And essentially what it's doing under the cover is calling database update for you, right? But it's in an exe. And I'll just show you quickly what that looks like. Okay, I didn't even put my thing on. So 3:20, 45 minutes, that's like 6 o'clock, right? I can just keep going? 3:20, 45 minutes, that's like, oh my God, you gotta be kidding me, I've done it again. That's like 5 minutes from now, right? This is the problem. NA Framework, I just want to talk about it so much. So the command line is .NET EF migrations bundle, okay? And then there's some option. Self-contained is the option that makes the big fat one with .NET built right inside of it. Force is to overwrite the file unless you use output to create other file names. Otherwise, it's always going to make a file called EF bundle. And you can also, when you run EF bundle, you can add a connection to it. So, oh my God, I want to do the temporal tables demo so bad, and I'm not going to have time. But I don't know. Can I just do another session after this? Is there, if there's only 2 sessions, I would totally do that. So what bundle will do is, and now I have to do all this nonsense again. Where did the time go? Okay. Discard all the files. Go to bundles. I don't care. Just make sure this is working. Now that the internet's on. Okay, yeah, it's fine. You're happy. Okay, so .NET EF migrations. What did I say? Bundle. Okay, so it's going to create that over here, building bundle. Oh, shut up. Okay, and there's EF bundle. And so this is the same little model. I didn't even show you because I'm like, I want to just go fast. So I just have this one migration in there, and it just creates the same, it's the same model for the people and the addresses. And this one's going to create a SQLite file. So when I run it, so ./EF bundle. So you can change the name of it if you want, but that's just the default name. So there, do you see that popped in there? There's the database that just popped in there. So you can bundle them up and deploy them and run them in different ways. You can, put them in. You can put them in CI/CD. You can put them in containers, et cetera, et cetera. So the most fun demo, which is going to be temporal tables, I'm just going to hand wave through it. I'm just going to fly through the rest of this so that you're aware of some of these things. Does anybody use temporal tables in SQL Server? I did not even know what they were, because when they were like, oh, we got temporal table support, and all these people were like, yeah. I was like, whoa, what are they? So I had to go and learn about that. So for those of you who don't know, it's a SQL, it's not a standard, but a lot of SQL databases do this, and SQL Server has their own implementation. So this is what it looks like in SQL Server Management Explorer. here's the people table, and within there, there's like this subtable, and it's called history. It's a history table. You don't create that table. You just tell SQL Server that, there's certain syntax to say, when I create this table, I want it to be a table that keeps track of has the history, temporal tables. So the table is actually, the history table mimics the main table. But notice also that it has these two columns here, period end and period start in both of them. So if you're doing this manually in SQL Server, you have to create these. You have to create those. But and you have to make, depending on what you name them, you have to let SQL Server know these are the tracking columns, and these are this is the name of the one for starting, and this is the name of the one for the end time. And then you don't have to worry about anything else. So anytime you make a change to data, SQL Server will take like a snapshot of what it was and stick it in the history table and say this was the data until this moment in time, right? So it was from whenever it started to this moment in time. And then the new version of the row says from this moment in time until the end of time, this is what it is. And then the next time you do it, it updates again. Really cool. So EF Core 6 lets you specify that you want temporal tables, so it's just a mapping, so you don't have to do all that work of specifically designing the tables with a history table. And all you have to do is in the toTable method, you just say it is temporal. That's it. And then when you run a migration, when you create a migration based, that is seeing this mapping, it's going to add those start and end time columns, and also some specific annotations so that when migrations reads that file and creates the SQL, it knows what to do and what it will do. So again, the only thing you're doing here is temporal mapping. Migrations does all the rest, and then it creates the SQL. When you're creating the tables, it creates the correct SQL to create the table correctly. And then the other thing that we have, and so SQL Server has methods for saying, I want to just query regular data, right? You're not doing anything special. But if you want to query, I want to know what the data looked like from this time, or there's a number of different methods you can use. So those exist in SQL Server, and then they're exposed in the provider. So we actually have these methods now in Link to actually query these tables. So you can do the whole flow of it. So SQL Server will take care of doing all the updates, but now once that's there, then you can actually take advantage of that temporal data when you're doing queries. Then just quickly, if you've used mappings to change things like, you always want a string to be an nvarchar 100 instead of nvarchar max. We used to have to do it for every single entity, every single instance of any property throughout your whole model. Now we have bulk configuration. So for example, have column type goes into a new method called configure conventions. So we just say, every time you see a property of string, it's have column type. And we can also use that with conversions. That's more about that. Document DB, there's all kinds of improvements for Document DB. Most important one is that it understands by default to have subdocuments, right? So it doesn't treat Document DB, Cosmos DB, like a relational database. And who uses group by? I hate group by because it's so hard to do. Okay, well, there's some really good improvements in group by, so they're getting more parity with EF6 for group by. Mostly it's beyond aggregate methods. Now we can actually drill into the properties of those related data that you're grouping by. So and also it lets you do top-N queries, which we could never, people really ask that for. asked for that for a long time. Also, who's coming up and speaking next? Are you here? Come on up and start setting up. I'm just going to say this one last quick list of EF7, which is, here's some things to look ahead to with EF Core 7. So big improvements for save changes are coming. Custom conventions, so that's something that's really going to be helpful even beyond like those bulk configurations. Bulk update and delete, we've been asking for that for years. JSON column support, really important feature. More interceptors, for those of you who've been around since the beginning of EF, we've got one for object materialization. Aggregate functions for different providers, so we can take advantage of different databases' abilities when we're doing queries. And we can, more EF6 parity, we can map stored procedures. We're going to have some T4 templates so you can do your custom scaffolding. And we've got entity splitting, and that's everything. And I am really sorry I went a few minutes late. But that's all of it. So one thing I do want to tell you is I've done this talk numerous times with more time available to myself, and I didn't, so that's not a problem. And those are on YouTube. I even did just the performance one. I did a couple just for fun on my own on YouTube, and I just talked for as long as I wanted because I wasn't being rude to the next speaker. Anyway, so thank you so much. I hope there's stuff in there that's of interest to you, and I'll be out in the hall, and you can ask me any follow-up questions if you want to.